Hi, I'm Steffi Leni Angubima. You can call me Leni. And the paper that I selected is How Does Batch Normalization Help Optimization? I create this video since it is a part of final subject, final project of my summer subject, which is the mathematical engineering of deep learning. Yeah, oh God, I really love this subject. We have known in general, batch normalization can be really helpful to improve the performance of architectures um, of models in on training session. Yeah, now I want to demonstrate you how batch normalization can improve the model. And I use a Google Colab for running the data, and I use Keras package as well, and then I use CIFAR 10. I use this one since the paper that I selected is using CIFAR 10 that dataset as well, which is comprised of 60,000 examples that size 32 times 32 pixel color photographs of objects from 10 classes. And then I divide the dataset become two data sets, which are training and test dataset. Training is consisted of 50,000 examples, and while the test dataset is consisting of 10,000. Then I normalize the train and test dataset. This is the modeled a 3-block VGG style architecture. You can see there are 3 layers, and then I add a flattened layer as well that has 128 units and then 10 units in the output layer. And every layer I add activation function, which are ReLU, and then I add softmax in the output. I use the learning rate 0.01, and then with 200 epochs with mini batch is 64. So you can see that the percentage accuracy is 73.7%. And then this is the graph of cross entropy loss. The train data set converges to 0, while the accurate classification accuracy, the train data set, it converges to 1. And then model 2, the learning rate is increased to 0.05, so the accuracy is increasing as well. And then I add a batch norm in each layer. Yeah, you can see I add here the batch norm in each layer of the hidden layer. And then the learning rate is 0.01, so the accuracy is significantly increased, become 80.5%. And then I increase the learning rate, become 0.05. The accuracy is improving as well, 82%. And then I change the learning rate, becomes 0.1. The accuracy is improving as well, become 82.44%. After I demonstrate the VGG architecture, I want to show you the model, the fully connected neural network with 4 hidden layers. In the hidden layer, there are 4 hidden layers, which is the first hidden layer is 400 and 200, 150, and then the output is 10. And every hidden layer has the activation function, which are ReLU, and then the activation function of the output layer is softmax, and then the learning rate is 0.001. The accuracy is 53.9%, and then I normalize the model, so the accuracy is improved. It's improving. You can see the and the graph of loss entropy. I mean the entropic loss and the classification accuracy. Then I change the learning rate as well, become 0.1, and then the accuracy is increasing as well, become 54 and 0.75%. It can be noticed that the performance of the model with batch norm is much better than without batch norm. And then I plot the picture from the graph from the paper. Yeah, you can see that we find a gap between optimization training and with the generalization or test accuracy. Yeah, surprisingly, when the distribution over a batch is plotted, it shows that here the distributional stability, like change in mean and variance in network with and without batch norm layer seems slightly different. It means that the batch normal doesn't relate to to internal covariate shift. Yeah, I think that's all. Thank you so much for the time.